Hey guys, it's Miss Landry, and I'm going to be talking today all about classification of matter. So we've learned a lot about matter, and we know that matter is basically anything that takes up space and has mass, right? So if it has volume and it has mass, then we can consider it matter. And remember from your previous lessons that pretty much anything in the universe that is tangible or visible probably has matter. Now, some of the things that we talked about that aren't matter are things like a rainbow or your thoughts, but pretty much everything else is matter. So let's look at how exactly we are going to classify it. So matter can be broken down into two main categories. Okay, so the first one, I'm going to put some stickers here, hopefully you like them, is a pure substance. Okay, the pure substance is something that has, how do I want to say this? It has a set ratio, meaning every part of, fixed ratio is another way we say it. But basically, every time you have that substance, it has the same ratio of pieces in it. So for example, if I look at salt, salt is NaCl, right? Sodium and chloride. It is always the same ratio of sodium to chloride. So that would be a pure substance. Sugar is another one. Sucrose or glucose, C6, H12O6, always in that ratio, always, no matter where you get it from. Another thing that a pure substance has is it is uniform, meaning no matter if I take salt from the ocean or salt from my table, if it's all sodium chloride, it will always be sodium chloride. So it's uniform throughout. It's always going to have that same ratio and it's going to be uniform. So like I said, examples of this would be NaCl, which is table salt. Carbon dioxide is another great example. You could have just oxygen, right? Oxygen's a great example of a pure substance. And I think I said sugar, which we all love, C6H12. That's kind of hard to write, H12O6. Now, there's lots of different kinds of sugars. The one I'm writing there is glucose, but all sugars have a ratio that is the same. So that is a pure substance, and we'll go into it even further. But let's talk now about mixtures. So what is a mixture? So let's put a little sticker on mixture too. Yay, mixtures! Okay, and what is a mixture? A mixture is anything that is made up of, let me write this for you, anything that's made up of two or more things, okay, that are physically put together and can be physically separated. Meaning you don't need a chemical reaction in order to separate them. Let me finish this. Put together. That's hard to write with a clicker, I have to say. I'll just put tog. Okay, so a mixture is anything that's kind of mixed together but can be separated pretty easily through physical means. So let's talk about what are some examples of a mixture. Salad is a great example, right? So we mix lettuce and tomatoes and croutons and cheese in your salad. You can easily separate them. One that's not so obvious would be air. So air is a great example of a mixture. It has nitrogen, it has oxygen, I believe it has some argon in it. It even has some carbon dioxide. We all know it has some methane. So that's an example of a mixture because we can actually separate those out without having to do it chemically. So we don't have to, when I say chemically, I'm thinking of like if you look at water, which is a pure substance, okay? In order to break the hydrogen and the oxygen apart, I would have to use some kind of chemical means. But if I wanted to separate all these gases that are in the air, I can do that without having to break them apart chemically. So that's a pretty easy way to think about the first two main breakoffs of matter and how we classify it. So now let's go to the next slide. I'm going to clear this screen. Whoops. And so that was matter. Now let's take a look at specifically pure substances. Okay, so we talked a little bit about pure substances, and hang on. So in the last slide, we had matter, and we divided it. Oh my gosh, sorry guys, hang on. We had matter, and we subdivided it into pure substances and mixtures. So that was our last slide, this little bit at the top here, okay? But now what I want to take a look at is how we break down pure substances. All right, so here we have pure substances, which we talked about before, which are things like oxygen. It could be gold, which is AU on the periodic table. It could be CO2. Okay, so these are all different types of pure substances. Remember, they have to have a fixed ratio and they have to be uniform. So we can break these down, though, into two more things. We can break them down into let me put more stickers on here. I love my stickers. We can put them into an element, or we can break it down into a compound. So let's talk about what each one of these are, okay? So an element is basically a single, how do I want to say this? A single type of atom, or a single chemical off the periodic table. So for example, let me finish writing chemical. I can have oxygen. Now, oxygen is something we call a diatomic molecule. You don't need to know that for this class yet, but basically it just means when it's found in nature, it's found together, di, meaning two. Another example would be gold, which I said. It could be carbon. It could be sodium. So these are all elements, right? So they're single elements. You can have more than one as long as they're the same element. Okay, so I can have, what's another diatomic? I think chlorine is another one that's always found together in two. So that's an example of an element versus a compound in which you have two or more elements together and they can be different. So this would be like NaCl, right? So we have sodium and we have chloride. So that's a compound. We could have water, H2O. That's an example of a compound, okay? Because we have two hydrogens and an oxygen. Sugar, which I've talked about before, C6H12. You'll remember this by the end of class. O6, that's a compound, okay? It's still a pure substance because every time you find sugar, it's always going to be in this type of ratio. Same thing with salt. It's always going to be in this ratio and it's uniform. So it is a pure substance. So that is a compound. So the difference between an element and a compound would be an element would be a single type of chemical off of the periodic table. So that's pretty easy, carbon by itself, versus a compound where multiple are kind of combined together chemically. Now these are chemically bonded, right? So that's different than a mixture where they're just physically put together. So in order to separate sodium and chloride, I would have to use some type of chemical process. Same thing with sugar. In order to break those apart, which we do in our bodies with digestion, I would have to use a chemical process. So I hope that clears that up. And then the